In this video, we're going to look at completing the square and how to solve a quadratic equation by completing the square. So first, we're going to look at the motivation of completing the square. So we're going to start with the perfect square and try to see how we reverse it from this example. We learned this type of question before, how we square x plus 3, a binomial. So again, it's not gonna, you cannot distribute the exponent to x and a 3 because it's plus. Distinguish this question from x times 3 squared, which can be done by x squared, raise x to the second and 3 to the second, and that gives us x squared times 9. But with plus, we cannot just say x squared plus 3 squared. That's incorrect. So be very careful. This is not equal to x squared plus 3 squared. The correct way to do it is to use the definition of the second power, which means multiplying 2 copies of x plus 3. And to do that, we can use FOIL or just distribute. So x times x is x squared. X times 3 is 3x. And 3 times x is 3x, and 3 times 3, that gives us 3 squared. And we can combine like terms here. So x squared plus 3x and 3x. Notice we have 2 copies of 3x, which gives us 6x, and plus 3 squared, which is 9. So when we try to reverse the process, so if we are given x squared plus 6x plus 9, and certainly we could do factoring, but the other way to do this question is if we look at the numbers, the coefficient of x is exactly twice of this number right here. And as you can see, why we got twice of that number? Because we got to combine these 3 copies of 3x. That gives us twice of 3. And the final number is 3, that number squared. So notice that this number right here, if we take it, how do we find the relationship between the number in front of x and that number there? It's exactly half of the coefficient of x. So when we try to reverse the process, we look at this number in front of x, not x squared, it's in front of x. And we take that 6 divided by 2. So that's going to give us that number right there. And then we just need to verify whether we square 3, whether we can get 9 or not. Okay, so in general, if we have x plus a squared, and we would do x plus a times x plus a, similar to x plus 3 times x plus 3. And we use FOIL, we're going to get x squared plus ax, and plus ax again, and plus a times a, which is a squared. And notice these two x terms will combine to get us 2ax. So that number right there, the second term of the base, the binomial, is exactly half of the number in front of x. This is twice of that, which means that number is half of the coefficient of x. So that's something we need to remember. So now let's look at an example of a completing square. So maybe I don't necessarily have a plus 9 there. Maybe I have a plus 8. And so how do we, this will not be, we know that a perfect square has to be x squared plus 6x plus 9. It's not going to be plus 8. But we can still do partial perfect square with the extra number there. So this process is called completing the square. So this is the steps we're going to do is step 1. So we're going to take the number in front, look at the number in front of x and take it divided by 2. So in this case, we get 3. And then we are going to, and if we have 3 here, to get a perfect square, we know that the last term, the third term, must be that number squared, 3 squared. So we're going to, step 2 is we're going to take this number we got and square it. I'm going to just write as 3 squared. Actually, you can write 9 there. and immediately subtract it. The reason we're doing that is because we don't want to change this expression. So if we add 3 squared, we add 9 to this, it will change the expression. But we're going to immediately subtract 3 squared. And notice that 3 squared minus 3 squared, these two will combine to 0. So it's like we are adding 0 to this expression, which will not change it. But by the way, we still have plus 8 there. We technically, we're supposed to do what we're doing is x squared plus 6x plus 8, and then add 9 minus 9. Because after we cancel 9 minus 9, we still have exactly the same expression. But we're not going to cancel them. We're going to take the first 9 and move it, switch with this 8. So we're going to put x squared plus 6x plus 9 together. Thus, we know this is a perfect square. And the other 9 minus 9, we're going to combine that with the 8. So these two, we can combine them. Okay, now let's work this out. And as we mentioned before, this is going to be a perfect square. And because, as you can see, that the number in front of x is twice of the second number here. And also the final number is the third term is exactly 3 squared. Okay, the reason is we're going to multiply 3 and 3. That's going to give us 3 squared. So that these first 3 terms will give us perfect square. The rest of them, minus 9 plus 8, we just have to combine that to get a minus 1. So this process here, so we get a perfect square right here. Although there's a minus 1 or plus something, we do have a perfect square here. And this is actually the idea of the quadratic equation, how we solve the quadratic equation, how we get the quadratic formula. Sorry, I meant to say the idea of quadratic formula. So now we're going to look at an example to show this how to use this process to solve a quadratic equation. And we know that we could, if this trinomial is factorable, we could use factoring to solve it. But unfortunately, this one is not factorable. And we have to use a different way. So the first way we could do is, from previous section, we know that if we have something squared equals a number, let's say equals maybe 2, and this question mark, whatever that is, can be solved by taking the square root of the right-hand side number, because that's going to give, and also it's going to give you 2 solutions, plus or minus, because positive squared is positive, negative squared is also positive. So that's why we have 2 solutions. But in this case, we can't do it this way because we don't just have something squared, we have also a first term, a degree term. So we cannot just say, okay, let's move this to the right-hand side, and then we take square root of both sides and add a plus or minus. Then in your answer, you will still have 3x in there. So if somebody asks you what x is, you cannot say, okay, x is 3x square root of 3x minus 1. We still don't know what so we need to, what x is. So we need to, so this is incorrect. We have to solve for x to tell what the number is for x. So what we can do is, this kind of gives us an idea. If we can get a perfect square without this x here, that would be good. So the process we just did it before, x squared minus 3x plus 1, we could try to make this a perfect square, because after we do that, and we just end up with a plus or minus a number here, and without x anymore. So this x is the trouble. So we're going to do complete square to get rid of that. Okay, there are a few ways you could do. In the textbook, they moved this to the right-hand side, which you can do that. But you could also do the same way we did it before. So either way is fine. So I'm going to show you both ways. So the way we did it before, if I keep plus 1 here, so what I'm going to do is, remember the first step, we're going to take the number in front of x. This time we have a negative, so we also have to take the negative sign and divide by 2. So we're going to get negative 3 over 2. And step 2, we're going to square whatever this number we got, to square this, and we learned this before, so it's going to be 9/4. And step 3, we're going to add 9/4 and minus 9/4 to whatever we have. So this is we're gonna take what we have, x squared minus 3x plus 1, add 9/4 and subtract 9/4. And the reason to do this is because we can use x squared minus 3x, these two terms, plus the number we have, this one, okay, and combine the other two. Combine the one they have and negative 9 minus 4. So put these two together and put these three together. And that is going to be a perfect square by the way we're doing it. So remember, the number you're going to be write down is you're going to write down is exactly the same as the one we get from the first step. And the reason is what we said before, because this number is always going to be half of the number in front of x. So that's why we know that this number should be half of negative 3. And after we square negative 3/2, and remember the last term is always going to be this number squared. So that's why we take this number we got and square it to put it right here, because that's what multiplication is. So we can take a look. So this number is always going to be that number squared. See, this last number is always going to be this number squared. So that's why we take negative 3/2 and square it and put it right here. So it's going to make it a perfect square. And you can verify that x minus 3/2 squared is going to be exactly equal to, so it's going to be equal to x minus 3/2 times x minus 3/2. And when you multiply these two, that gives you x squared. When we multiply these two and these two, that's going to give us negative 3/2 x minus 3/2 x. And then when we multiply these two numbers, and that's exactly plus 3/2 squared. Okay, or plus negative 3/2 squared, because negative 3/2 times negative 3/2, that's negative 3/2 squared. And after we combine these two, that gives us twice of negative 3/2, that's exactly 3x. Okay, doubling that, that's 3x, and with the minus sign, and that gives us 9/4. So that matches that. So usually after you do these two steps, 3 steps, these 3 will always give you a perfect square. If you didn't make any mistake, you don't have to double check. This part is not necessary, so you don't have to do this. I was just trying to show you to verify this is equal to that. And combining these two, so we can equal the denominator times 4 times 4. So that gives a negative 5/4 equals 0. Okay, so now we're going to move this number to the right-hand side. And that gives us x minus 3/2 squared equals 5/4. So by adding 5/4 to both sides. And now we can use that property. So anything squared. So if we have something squared equals 5/4, you can take a square root of both sides, and the square cancels square root. Whatever the question mark is going to be equal to plus or minus square root of 5/4. And so we're going to do the same thing here. Let's use a different color. So we can take square root on the left-hand side and take a square root on the right-hand side and put a plus or minus in front of that. So this square cancels square root. We're left with the x minus 3/2 on the left-hand side. On the right-hand side is plus or minus. I'm going to go ahead and simplify this radical because fractions are not allowed under the radical sign. So I'm going to get square root of 4 over square root of 5, square root of 5 over square root of 4, which is equal to half of square root of 5. Okay, so now I am going to write this up here. So I got x minus 3/2 equals plus or minus square root of 5 over 2. And to get x by itself, I just need to add 3/2 to both sides. So I end up with x equals plus or minus square root of 2 plus 3/2. Okay, You can switch them. Usually you can switch them to get 3/2 plus or minus square root 5 over 2 for our x.